Evolution is a theory that many people are familiar with. We learn about it in school, see it in museums, and often hear about it in the context of biodiversity. However, evolution is still one of the most misunderstood scientific concepts in the public sphere. If I asked you how evolution works, you'd probably think of some key terms from high school biology, such as survival of the fittest and adaptation. But what does that mean practically? How does one animal transform into another? How do species diverge? Many people have misconceptions about the evolutionary process. Outdated theories of evolution are common in mainstream and social media, and this has skewed the public's perception. Most pervasive is teleonomy, or the idea that natural selection is goal-oriented. People often mention how fish grew legs so that they could walk on land, or how zebras became striped so they could hide in the tall grass from predators. It may sound like semantics, but this line of thinking ascribes an objective to nature. Rather, these changes came about naturally and randomly, and happened to be advantageous enough that they remained features of these organisms. In addition to teleonomy, evolution is often substituted with what I like to call Pokemon evolution. In this view, animals evolve into a more advanced form, like Bulbasaur evolves into Venusaur. This is wrong for two reasons. One, species do not just change from one to another. During speciation, subpopulations change according to their environment, resource availability, sexual competition, or simply random mutation until they are no longer able to interbreed with the original population, marking them as a distinct species. This is not a linear process, and instead looks more like new species branching from an ancestor, often even outcompeting the original population into extinction. For example, people often think that dinosaurs like T-Rex evolved directly into birds. This isn't really what happened, as rather than all the dinosaurs evolving into birds, birds separated from the dinosaur tree until they eventually became a distinct group. They had dinosaur ancestors and are still technically dinosaurs, but they are not directly descended from many of our more familiar dinosaurs like T-Rex. And two, new species are not necessarily more advanced than their ancestors simply because they are more evolved. Speciation does not make species inherently any more or less complex, and can often coincide with loss of genetic material or physical structures. So how does evolution really work then? At its most simplified, random mutations cause organisms to differ slightly from their predecessors, and those that are most fit, or better able to survive and reproduce in their environment, pass down these new genes to their offspring. That's it. All said and done, I hope you learned a thing or two about evolution today, and that you now have the knowledge to challenge inaccurate representations of this theory.